Hello everyone, today I am excited to present our proposal on hybrid automated cars. The global hybrid vehicle market is rapidly growing, projected to reach USD 5,006.35 billion with a CAGR of 28.8%. Traditional fuel-powered vehicles contribute significantly to resource depletion and also environmental damage. Thus, the transportation sector needs a sustainable shift and hybrid and also electric cars in order to offer a cleaner alternative with better fuel efficiency and lower emissions. Our proposal focuses on developing an advanced hybrid automatic car using cutting-edge technology to reduce environmental impact while providing a seamless driving experience.
Okay, now moving on to the literature review, we first look at the article, The Effect of Internal Combustion Engines on the Environment, where it revealed the adverse effect of fuel-based vehicle to the human health and mental. From this article, we justify the proposal of converting ICE vehicle to EV. The second paper, Converting an Internal Combustion Engine Vehicle to an Electric Vehicle, discusses the model development and process of converting ICE vehicle into EV, where it revealed the three crucial power electronics required in the mechanism of an EV, which are rectifiers, choppers, and inverters. In the third paper, AC to DC converter for electric car application, discusses the mechanism of rectifiers in the application of electric system, where we learn that rectifier is used in EV to convert AC from the grid to DC to charge the battery and power the motor. The fourth paper, Power Electronics and Drive used in automotive applications, are referred for the application of choppers and inverters, where we learn that choppers are used to regulate various DC levels for powering electronics such as sensors and air conditioning, and inverters are used to convert DC from batteries to AC to power the motor for generating mechanical movement.
The first one, methodology, is research, study and analysis. Market value of hybrid cars, gather information on the current market value and significance of hybrid cars. Then power electronic conversion system, it will give insight into this system and their role in vehicular power system. Next, for electric car innovation, it will explore as the latest innovation in electric cars. Then advanced vehicle power system focus on power electronics intensive solution for electric, hybrid electric and fuel cell vehicle. Then the second method is system architecture design. Design project requirement, it will identify performance targets, energy efficiency goals, operational limits and regulatory compliance standards. Then the stakeholder inclusion, it will ensure stakeholder alignment with project objectives and user needs. And then power electronic conversion system design, it will design components such as electric motors, battery system and three conversion stages, which is AC to DC, DC to DC and DC to AC. Then the next method is simulation and prototyping. Simulation tools and modeling technique assess system performance under different conditions by examining key metrics, which is efficiency, voltage regulation, power factor correction and harmonic distortion. This will optimize the design and operation. For prototype development, we develop prototype of power converter AC to DC, DC to DC or DC to AC to evaluate efficiency, thermal performance and reliability. Then, for integration testing, it will verify compatibility and interoperability of various system components through control testing. And then, the next method is testing and validation. Comprehensive testing will validate performance, reliability and safety through bench testing, field testing and compliance testing. Continuous refinement will improve energy efficiency, battery performance, thermal management and component reliability based on test result and stakeholder feedback. And the last one, for the final testing, it will assess overall performance of electric car and power electronic conversion system, evaluating metrics such as energy efficiency, range charging time and reliability to ensure project objectives are met. The next one is cost analysis and budgeting. Estimate total project costs include material, labor, equipment, testing certification and overhead. Consider both initial investment and ongoing operational expense. Effective resource allocation, stay within budget, prioritize investment based on project priorities, collective critical path activities and risk management. And the last method is project development and training. For the training program, we provide comprehensive training for project team members, technician and maintenance staff. User manuals and documentation are also provided to develop material to guide bus operators, maintenance personnel and end user. And the last one is ongoing support and training. It will offer continuous support and training for successful deployment and operation.
Okay, for my design, I propose this configuration for the EV system. The way it works is an ultra capacitor charger will take AC power from the grid and a rectifier will convert them to DC. The DC will be regulated by two choppers, one for the lithium-ion batteries and another for auxiliary battery for smaller electronics. There are 20 units of lithium-ion batteries connected in series to generate a high power. And a curtains controller will connect the lithium batteries to brushless DC motor, where it will regulate the power supply based on the pedal. An inverter will be used to convert the DC from batteries to AC, suitable for powering the BLDC motor. The BLDC motor will convert the AC power to mechanical energy to drive the vehicle.
Moving to the second design, which is the design on the power transmission of FCEV, which is stand for Fuel Cell Electric Vehicle. As you can see from the figures shows beside, it is the general scheme of a FCEV power transmission structure, including auxiliary power supplies. There are a lot of core components that is used in this design, such as fuel cell stack, hydrogen tank, unidirectional DC-DC converter UDC for FC side, and also bidirectional DC-DC converter for auxiliary side. For the control system, the electronic driver control for either AC or DC motor control, and the DC to AC converter, which is act as inverter, supervise motor speed and torque for safe operation. For the energy flow, fuel cell stack supplies energy to the DC bus, maintaining required bus voltage, and unidirectional converter keeps DC bus voltage constant and transfer the energy to motor drive converter. Thus, electric motors will be controlled by the drive controller and then convert electrical energy into kinetic energy. From the FCEV hybridization car design, we have choose two proposed model, which is full fuel cell electric vehicle (FCEV) and also fuel cell plus battery hybridization. As you can see from the right side, it is the table of the comparison about the performance of all types of FCEV models. Thus, from the comparison, we have chosen these two models as it has the highest efficiency and also have the highest energy density.
Then, for my design, I propose about series hybrid propulsion system. The first one, you will see a typical comparison of a series hybrid propulsion system figure. In a series hybrid vehicle, the engine is coupled to a generator, which in turn charge the batteries. The power electronic system in the system are alternator output converter, engine to alternator, which make alternating power. The battery pack must also be charged with DC power. The AC power that will eventually reach it must be converted. And AC-DC conversion is performed using a power electronic converter, which is usually a rectifier circuit. It will maintain the DC voltage level to the battery pack level by regulating the converter. Then, inverter propulsion motor. The battery pack store DC energy. That said, the propulsion motor does need AC to work. The DC comes from a battery which is high voltage and an inverter circuit is employed with power semiconductor switches to change the DC to AC suitable to the motor. The inverter controls the motor speed and torque in a more accurate and quick way by controlling the frequency and voltage of the AC supply. Besides, DC and DC converter for 12-volt framework, in expansion to the high voltage battery pack, vehicle have a 12-volt existing battery. A DC-DC converter step down the 12 voltage from the most battery pack to charge and control the 12-volt framework. This 12-volt framework supplies controls to different vehicle hardware, lights and infotainment. Inverter for electric discharge conditioning. Conventional vehicle discharge conditioning framework are mechanically driven by the motor. In an arrangement crossover, an electrical-driven discrete conditioning framework is utilized. An inverter change over the DC from the battery pack to the specified AC supply for the electric discrete conditioning engine. This permits free operation of the discrete conditioning framework from the motor.
The benefit of converting ICE vehicle to EV in the social and health aspect, that it will significantly reduce the carbon emission, which in turn reduces the number of health implications associated with it. In the economic aspect, the rise of EV usage will drive the investment in new infrastructures in the EV and energy sectors. So it will increase the job opportunity in that sector.
As the conclusion, our project aims to convert a fuel-based automatic car into a hybrid electric vehicle using advanced power electronic systems such as AC to DC rectifiers, DC to DC choppers, and DC to AC inverters. In this assignment, we have focused on reducing greenhouse gas emissions by improving fuel efficiency and enhancing environmental sustainability with a proposal of electric vehicle hybridization application of power electronic system. Moreover, we also take consider about the budget and economic benefits, which are we have in this assignment there are a budget of MYR 800,000 for a comprehensive research, development and deployment. Therefore, we have promised a significant economic benefits and robust ROI for our investor so that they can invest to our project. Last but not least, we have aimed the feasibility and long-term goals in this assignment. In order to achieve that, we have demonstrated the feasibility and advantages of vehicle electrification and contributing to energy independencies and also environmental preservation. In the end of the assignment, we have come up with 3 different designs of proposal for our project, which are electric vehicle, fuel cell electric vehicle, and also hybrid propulsion system for electric car.